today is precipitation reactions, and today you are going to learn how to write a net ionic equation as well. Precipitation reactions. We are at the 16th. Tomorrow in class you're going to do an activity where you're going to create a precipitate so that you can actually see what this looks like. I would do a demo for you right now on camera, but then it would ruin the fun for tomorrow. So tomorrow we will do a small activity to show you what a precipitation looks like, precipitation reaction looks like up close and personal. Alright, so this is all very abstract. A precipitation reaction. A precipitation reaction results in the formation of an insoluble product. Also known as a precipitate. A precipitate is an insoluble solid that separates from the solution. So what does insoluble mean? Insoluble means does not dissolve. Soluble, it dissolves. Insoluble does not dissolve. So, soluble dissolves. If something is soluble in water, that means it dissolves in water. Insoluble does not dissolve. Soluble means it dissolves. Insoluble means it does not dissolve. Alright, so a precipitate is a insoluble solid, and it will actually separate out from a solution. And again, you guys, you will see it tomorrow. Okay, so now what we're going to do is we are going to have our first experience in writing a chemical equation, this chemical equation and predicting the product. So this chemical equation is going to represent the activity that you guys are going to do tomorrow in class. It will be a very, very quick little activity that you're going to do, but we're now going to write the equation that represents that. We need a lot of practice at this, so let's not have any panic. So in a precipitation reaction, we've got two soluble ionic compounds to begin as our reactants. So, for instance, lead to nitrate it's aqueous, is going to react with potassium iodide, which is also aqueous. Okay, so when you're doing your problem sets tomorrow, you guys, you're going to be given those two. And then what you have to do is you have to predict the products. And then, from the products given, decide which one of them is soluble and which one of them is insoluble. And you will do that using your solubility rules. Okay, so how do I predict what is going to form here? Well, we're going to do something called a double replacement reaction. This is a double replacement reaction, which means that the cations switch places. The cations switch partners. So the lead is going to pair up with the iodide, and the potassium is going to pair up with the nitrate. So the cations are going to switch places. A double replacement. Potassium replaces lead. Lead is going to replace the potassium. All precipitation reactions are double replacement. So what that's going to give us, you guys, as a product is lead 2 iodide, plus potassium nitrate. Okay, now, using the solubility rules, which we're going to do tomorrow in class, what I know from my solubility rules is this is the solid. That is our precipitate. Okay, I know the solubility rules, so I know that. You don't know them yet, but you will tomorrow. This is not a precipitate. This is an aqueous solution. Okay, so this stays aqueous, and that is our solid. Okay, so is this equation balanced? I don't think it is. We've got lead, and we've got a lead, and we've got 2 nitrates. We only have 1. We've got a potassium. Now we have 2. And we have 2 iodides, 2 iodides. So let's try it again. Lead, 2 nitrates, 2 nitrates, 2 potassiums, 2 potassiums, and 2 iodides, 2 iodides. Okay, you guys, we've got 2 iodides here in this compound, but only 1 iodide here. Okay, why do I have the subscript of 2? Because this is lead 2. This is an ionic compound. In order for it to be to be electrically balanced, I'm going to need 2 of these -1 iodides. Okay, so this is where we have to know the ions. This is where we have to know how to write compounds. We've done practice with it, but we haven't put that knowledge into practice, and this is where we're going to have to do it. Okay, so we say that this is a complete molecular equation. And that's fine. That shows us reactants and products. And that shows us the stoichiometry in terms of mole ratios. How much of what reacts with the other. Okay, but it doesn't really show us what is going on at the molecular level. Because this is aqueous, people, what do we know about this really? Is this associated together? No. This is dissociated. It's ionized in water. This is not ionized in water. This is a solid. Water can't break this thing apart. But this is dissociated, and we know that because it says aqueous. This is dissociated in water. Really, this is just potassium and iodide floating around separate from one another. And in this case, you guys, in water, aqueous, we've got lead 2 ions floating around, and we have nitrate floating around. So this doesn't really show us on the molecular level what's going on. So what we're going to do next is write a complete ionic equation, which really shows us at the molecular level what this looks like. So, because this is aqueous, we know it is ionized or dissociated, so I'm going to write it like that. So, I'm going to say Pb2+, and that's going to be aqueous, plus 2 nitrates, aqueous, is going to react with 2 potassiums, which are aqueous, plus 2 iodides. Okay, so what this is showing us, you guys, what this is showing us is what they really look like on the molecular level. They're not associated. They are dissociated. Okay, so again, a complete ionic equation. And then we've got our products that we need to write. Now, this thing is a solid. So is it dissociated? No, it is not. It is together as a solid. So we're going to write it like that because at the molecular level, it's connected. PbI2. Because this is aqueous, this tells us this is not associated in terms of what it looks like at the molecular level. So this is split, this is ionized. So we've got 2 potassiums. Okay, so this, people, is my complete ionic equation. My complete ionic equation. Okay. Now the last thing we've got to do here, we've got one more, and that is a net ionic equation. So this shows everything. Everything that is in my beaker before and after the reaction. But it's showing us things that really aren't doing. They're just floating around. They are spectating. So the last bit we're going to do here, you guys, is we're going to write a net ionic equation. And in the net ionic equation, what we do is we get rid of what we call our spectator ions. Our spectator ions are just watching. They're spectating. And we recognize our spectator ions because they are identical as reactant as they are as product. So, we've got lead 2 ion. Do we have any lead 2 ion in this spot? No, we don't. So it's not spectating. It's actually taking part in the reaction. We've got 2 nitrates on this side. We have 2 nitrates on this side. So what we would say, you guys, I'm going to cross it out. We would say here that these are spectating because they are identical on both sides of the equation. 2 potassiums, 2 potassiums, identical on both sides of the equation. They're spectating. I'm going to get rid of them. 2 iodides, but they're actually forming something. Okay, something that is not spectating. This thing actually got bound up by lead. Okay, so our net ionic then is everything that's left over. We have lead 2, Pb 2+, aqueous. Is going to react with those 2 are spectating. We don't even want them in our net ionic. 2 iodides. And they are also aqueous, meaning that these were dissolved. And they are going to give us Pb I2, and that's a solid. This is the net ionic equation for what has happened here. So this one is the net ionic. Equation. This one is the complete ionic equation. This whole thing, I'm talking about this whole thing. And this one is the complete, we're just going to call it a molecular equation. Okay? We're going to practice with these tomorrow. I know that you don't know how to do this, but this is our start, and we will have lots and lots.